Hi everyone, so today we're going to talk about the Test1Wrapper for Physics 2211. Here is the test 3 from Spring 21, where there will also be a provided answer key. So specifically here we're targeting problem 1, where we'll specifically do parts A and B since they're connected, and this will involve me starting off the free body diagram that we will later translate to finding the final coefficient kinetic friction. So here we will see that we want to begin with two ways of finding a way to use Newton's second law. So there are two ways to draw the free body diagram. The standard way, where we see on the top where the force of gravity is pointing downwards and the normal force is pointing orthogonal to the surface. Also the friction going against the direction of the motion of the car, as well as its angle that we can see when we draw it out. And the other one is a translated and rotated sort of coordinate that allows us to better visualize how the force of weight's components move in both the vertical and horizontal components. So we understand that to find a coefficient of kinetic friction, one of the formulas actually means mu k equals ff over fn, and so from here we want to get the friction force as well as the normal force. So we know that this system is actually has constant velocity at some point, so that means net force is equal to 0 at some point. So here we can begin by first solving for the net force in the horizontal or x direction, and then later in the vertical or y direction, and then we can relate them. So in the x direction, we know that friction opposes the direction of motion caused by the component of weight going down the ramp. So then that's why friction has a negative sign assigned to it, as well as component weight having a positive sign. And then similarly in the y direction, we know normal force prevents it from sinking into the object, which opposes the vertical component caused by the weight, which is why the vertical component caused by the weight has a negative sign to it. So we can set f net equals 0 and f net equals y both equal to 0 and solve for both ff and fn respectively. And then from here, we can go back to our understanding the relationship between coefficient kinetic friction and force of friction as a force of normal force and relate them. So we can set coefficient of kinetic friction equal to force of friction force of normal force by setting it equal to its weight times sine theta divided by its weight times cosine theta, which we see that the constants cancel out in both the numerator and denominator, which leaves us with sine theta over cosine theta that we will simplify to get tangent theta. And from the question, we know that we had the angle with respect to the horizontal surface, and that was 35 degrees. And so we can take the tangent 35 degrees, make sure to use degrees, not radians, we should get 0.7.